Welcome to Chapter 3. Chapter 3 is going to involve parallel lines. And we're going to get into a lot of proving angles are congruent. And we want to go backwards and be able to prove lines are parallel. So let's discuss what parallel lines look like and some of our abbreviations for them. The first, parallel lines. Coplanar lines that do not intersect. So if I have two lines, say line A and line B, lying in the same plane, you can say that A is parallel to B. So our shorthand notation is the two lines that look parallel. So A is parallel to B in that case. Skew lines are non-coplanar lines that don't intersect. The two lines that do not intersect, mainly because they're on different planes. I like to think of that as, let's look at this room, right? If you look at the top of our board here, that line that goes on it, that went on and on forever, right? And then we look at the bottom line here, of where the floor connects to the wall, that goes on and on forever. Those would lie on the same plane as the wall that goes straight up and down, right? They would never intersect, they go on and on forever. Those are parallel lines. Skew lines are a little different. Let's take again this bottom of the floor right? If I looked at that corner of the room where the door is, that line that goes up and down, if those guys were on the same plane, they would intersect. But since they're on different planes, they never intersect. They're called skew. Okay? So skew lines, lines that aren't on the same plane, and therefore do not intersect. Parallel planes. Planes that don't intersect. Just as we have lines that don't intersect, we have planes that never intersect. Those are parallel. And the last new vocabulary is transversal, a line that intersects two or more coplanar lines. For transversal here, I'll put it in blue. That transversal T right there. That line that intersects those two lines, it cuts through two or more lines and we call it a transversal. All right, so what I'd like you to do is try example 1. See if you can find each of the following situations in regards to that figure on the right. I'll give you a few minutes for that. Let's see how we did. So parallel to AB, it contains D. So we have line AB right here. So parallel is going to be that one or this guy down here, FE, but it contains D. So it has to be CD. Perpendicular to AB that contains D. You could use DC as well. DC will define the same line. Make sure we're careful with our hat stuff. So this guy right here is going to be perpendicular to AB. So we have 80. And then let me erase some of these. Skew to AB that contains D. Well, there could be a whole bunch of those ones. Let's see any of these ones right here. ED, this guy right here, on a different plane would not intersect. DH going up and down here. And then DG, that side there as well. And then a plane with D is parallel to ABE. a plane with D and parallel to ABE. So ABE is this entire side here. So we're talking about this plane over here. So any combination of those three letters, how about DC and H? That defines our plane. So our parallel postulate, if there's a line and a point not on the line, there's exactly one line through the point and parallel to a given line. All right, so let's see. Let's draw a picture of this. Whenever I see these postulates, definitions, I always like to draw a picture so I understand what's going on. So, parallel. So if there's a line and a point not on the line, so let's say there's this point right here, there's exactly one line through the point parallel to the given line. So if I have a line out in space, right, and then I have a point, there's only one way you can have a line that'll go through this point that would be parallel. Okay? So the only way for it to be parallel, right, there's only one possible line. Next, our perpendicular postulate. If there's a line and a point not on the line, then there's exactly one line through the point perpendicular to a given. Okay, let's do that same thing. Create our line. And a point not on that line. Let's make this here. Mr. Smiley face. There's only one line that we can draw that will go through that point and be perpendicular to that line. So this turns out to be the shortest distance between a point and a line. The point that's perpendicular to that line, to that point. And the big idea is from this particular section. We want to look at these different angle types. I'm going to move this up a little bit. Let's look at this figure here. All right. So defining angle pairs and angle relationships. So corresponding angles is our first one. If I have two lines cut by a transversal, notice that we have 8 angles created. So we have 8 angles created. We've already looked at, if I just look at one set of these. So if I just look at, say, this top set of angles. So say I just look at these top ones. What do I know about 1 and 4? What type of angles are those? Vertical angles. We know vertical angles are always congruent. What about 2 and 3? Also vertical. What about 1 and 2? What type of angles are those? So linear. A linear pair. What do we know about linear pairs? They sum to equal 180. So the same thing is going to apply with all of those relationships, with all of these ones as well, right? But now in this chapter, we're going to look at the relationships between the bottom set and the top set. So the first one we're going to look at is corresponding angles. And I like to think about our coordinate plane, right? So our coordinate plane, remember how that works. We have quadrant 1, 2, 3, and 4. So if we were to graph a point, right, in quadrant 1, up here, it would correspond if I were to graph something in quadrant 1 down here, right there. So upper left is 1, corresponds to upper left in this group of 4. So the corresponding angles, angle 1 and angle 5. That's one pair of corresponding angles. The next, angle 2 is going to go with angle 6. See if you can come up with the next two. See if you can come up with the next two. So if we look at angle 3, what corresponds with angle 3? Angle 7, very good. And then angle 4 and angle 8, very good. All right, so the next angle pair relationship we have is alternate exterior. So when I have two lines cut by a transversal, I have the interior, right? These are between the two lines. And then the exterior, we have up here and up here. Right, so the interior between the lines, exterior on the outside. So alternate means on opposite sides of the transversal. So alternate exterior, we'd have angle 1 and angle 8. There's only one other pair of alternate exterior angles. See if you can come up with that. Hopefully we got angle 2 and angle 7. Very good. All right. So see if with your knowledge of alternate exterior angles, can you figure out what alternate interior angles are? So hopefully we're comfortable with angle 4 and angle 5. Opposite sides of the transversal, but on the inside. Alternate interior. And then angle 3 and angle 6. So 3 and 6. Consecutive interior angles. The other name for this is same side interior. We know they're in the interior, right? And same side means they are on the same side of our transversal. So I get angle 4 and angle 6. Right? Same side and on the inside. And then angle 3 and angle 5. Any questions on those relationships?